Welcome to Meki Study Circle channel. In this video, we shall see how to do the computer drafting of the orthographic projection of solids using the Solid Edge software. In this problem statement, we have got a hexagonal prism, 25 sides of base and 50 axis length, resting on HP on one of its edges of the base. Also, draw the projections of the prism when the axis is inclined to HP at 45 degrees and appears to be inclined to VP at 40 degrees. So if you just observe the problem statement, we can see that the given solid here is a hexagonal prism and each of the edges of the hexagon measures 25 Also, the axis length is 50 Coming to the resting condition, it is resting on one of its edges of the base, and also the inclined parameter here is the axis, which is inclined to HP at 45 degrees and also appears to be inclined to VP at 40 degrees. So even though it is the parameter which is going to change its dimension from the first position when it has to be taken to the third position, that is with respect to the VP. But since the word appears to be inclined to VP is given here, we can understand that the given angle with respect to the VP is not phi but the beta. So there is no need for us to construct the beta angle separately here. So with this data, let us see how to draft the solution for the given problem statement. So let us begin by constructing the XY line of thickness 0.18 So let us draw a line of any arbitrary length and then annotate the line as X and Y, resting of one of its edges on the HP. So now let us annotate this. So let us tell that it is resting on one of its edges A1, B1. But since this is the top view for us, A1, B1 is not visible, but the corners of the top face A and B is visible. So it is A, and then inside the bracket it is A1, followed by the corner B, and inside the bracket it is B1, followed by corner C, C1, D, D1, and next it is E, E1, and then it is F, F1. So we have got 6 corners. So now let us draw the diagonals in order to get the origin of the axis. So select the line option, ensure the thickness is 0.13. So since it is a prism, we do not have to highlight the diagonals. So any two diagonals is sufficient to show the origin of the axis. So from this point of intersection, let us intersect the XY line, and from here, let us draw the axis line of chain type, and the length will be equal to 50 So this is the length of the axis. Next, we will draw the projection lines from each of the corners. So from corner B and A, intersect the XY line, and then C and this O1 and FF1 will be on the same line. And then this is from the corner D1 and E1. So now let us complete the front view of the hexagonal prism. So for that, let us select a continuous line of thickness 0.50 So join all the endpoints first, and then since it is a prism, it should be having the rectangular face. So I'm going to just overlap this edge line on the axis line. So with this, we complete the front view of the hexagonal prism. So now let us annotate this. So this is the corner B1 dash, which is visible first, while the corner A1 dash is not visible, so it is inside the bracket. Similarly, this corner will be B dash, inside the bracket A dash, and here it is the corner C1 dash, which is visible first, then it is F1 dash, so it will be inside the bracket, and here it is C dash and F dash inside the bracket, and also O dash is also inside the bracket. So the axis is not visible here. Similarly, here inside the bracket it is O1 dash, and coming to this edge, it is D1 dash, which is visible first, and inside the bracket it is E1 dash, and here this is D dash, and inside the bracket it is E dash. So we will just place the annotations to the respective edge lines. So with this, we complete the front view of the hexagonal prism resting on one of its edges. So now we'll go for the next condition, which states that the axis is inclined to the HP at an angle of 45 degrees. So for that, let us select the front view of the prism, select all the edges along with the annotations, and then let us move this front view, ensure the copy is on. So keeping b1 dash a1 dash as the point of reference, let us move this towards the right hand side of the xy line, and then rotate the base of the prism in such a way that it is inclined at an angle of 90 minus 45, which is equal to 45 degrees. So we're going to incline the base at the angle of 90 minus the inclination of the axis line with respect to the HP, so which will be equal to 45. So we'll just move this so that we have got sufficient place to complete the third position. So now you can just measure. So the axis is overlapped by this edge line. So the angle between this edge line on the axis which is overlapped and also the HP is 45 degrees as mentioned in the problem statement. So now let us complete the top view of the prism in this condition. So let us draw the projection lines from each of the corner points. And also from this corner A1, B1, C1, F1, and also from D1, E1, we are going to draw the projection lines and then draw the horizontal projection lines. So you can just use the extend to next and extend this and then draw the projection lines from C1. So this is here and then F1 is here. So we'll use the extend to next, extend this projection line. So use the trim option to trim the projection line which is not required for our constructions, and also from the axis point, so from this point of intersection. So with this we complete the intersection points. Now let us draw the top view of the hexagonal prism. So let us select a continuous line of thickness 0.50. So we have to understand that b1 dash and a1 dash are the farthest corner points to the observer when viewed from the top. So now let us complete the top view of the prism. So let us begin with the top face of the prism, that is from corner A, B towards corner C, and then corner D is this point of intersection, and this is the corner E, this point of intersection, followed by the end point F and back to the corner A. Similarly, we're going to start off with A1, B1. So here it will be the hidden edge. So go for the hidden line. So from A1, B1, so you get this point of intersection. This edge will be hidden, and even this will be the hidden line. So rest of the lines will be the continuous line. So from this, that is F to E1, F1 to E1, and then D1, D1 to C1. So now we will draw the corresponding outer edges. So the edges here will be the hidden lines. So select 0.50 mm thickness and the dotted lines. So from this edge, you can just see that there is a small extrusion of this previous edge. So just trim this. So we'll use this line option now. So from here till here, again it will be the dotted line. So with this, we complete the condition in which the hexagonal prism is inclined with its axis at an angle of 40 degrees to the HP. So we will annotate. So we'll start with this. So this is corner A, corner B, corner C, corner D, corner E, and corner F. Similarly, this is the axis point O. So coming to the bottom face, this is, we'll start from here. So this is A1, B1, C1, D1, E1, and F1. And also this point of intersection will be O1. So here we can show the axis lines. Of what I'll do is I'll select the trim option. I'll trim this projection line connecting O1 to O. I'll select the line option, and then let me select the chain line of thickness 0.13 mm. So from O1 to O, this is the axis. So here the length of the axis is not required because anyway the given angle itself is the beta angle. So but this is the top view of the hexagonal prism when its axis is inclined at an angle of 40 degrees with respect to the HP. So now the same prism should be aligned on the vertical plane so that it is appearing as if the axis line appears to be inclined at an angle of 40 degrees. So for this, what we will do is we'll construct a 40-degree line first. Select a continuous line. Let us draw a line of any arbitrary length, but the inclination will be equal to 40 degrees with respect to the vertical plane. So use the angle between and then measure and show the angle which is equal to 40 degrees. So now let us select the top view of the prism. Select all the outer edges first. And now select the inner edges. Select the axis line, which is very important for us because it is the axis which is inclined. And now select the annotations. So proceed with this step only after you have made this a rigid set. So now we'll go for the move option. Ensure the copy is on. So keeping O as the reference point, let us place the point O on this 40-degree line. Select the rotate option. So keeping O as the first point of center and O1 as the second point of center, let us tilt the prism such that the axis is aligned at an angle of 40 degrees with respect to the vertical plane. So now we will complete the front view of this condition. So for that, let us draw the projection lines. So let us complete the top face first. So draw the three projection lines. So we'll start with the corner A, intersect the horizontal projection of corner A. Similarly, B is here. And then, okay, the point C is not selected. So this is the corner C. And then this is the corner D. Corner E is here. And then corner F is on this projection line of C. And then the axis point O. So from the point O, it has to intersect this line. So use the trim option, trim the projection lines which is not required for the construction. So now let us complete the top face of the hexagonal pyramid. Select a line of thickness 0.50 mm. So let us start with this edge AB. So for the observer, the farthest corner point will be the corner A. So from A, it will be the dotted line. So A to B is one dotted line, and A to F will also be the next dotted line. So the point F is here. So this is the projection from the corner F. So these two will be the hidden lines. Okay. So now we'll draw the other outer edges which are visible. So from F to E, so the corner E is here, then the corner D is here, corner D to corner C, and then C to corner B. So we'll just annotate this point which is missing here. So this is C and this is C1. And let us annotate the top face of the prism. So this is B dash, this is A dash, then this is E dash, and then this is D dash. So A, B, C is here, C dash, and then this is the corner E dash, and this is the axis point, that is O dash. So use the trim option. Okay, so since the point C is on the same line, we cannot trim this projection line. So now we will draw the bottom face of the prism. So for that, let us select again a line of thickness 0.13 and then redraw the projection lines. So only two set of lines is sufficient. So anyways, we have got A1 and B1 on the XY line. So now we'll connect C1, D1, E1, F1, and then O1. So use the trim option and just trim the lines which is not required for the constructions. So now we'll complete the bottom face of the prism. So go for the line option, select the line of thickness 0.50 mm. So we'll start with the corner A1 followed by B1, B1 to C1 is here, then this is D1, E1, F1, F1 to A1. So this is the bottom face of the prism which is visible to the observer. So now we will just annotate this. So this is A1 dash, this is B1 dash followed by C1 dash, this is D1 dash, corner E1 dash, and this is the corner F1 dash, and this is the axis point, that is O1 dash. So now we are going to join the outer edges. So select the line option 0.50 mm. So let us begin with, so A1 to A dash will be the dotted line, then similarly okay, so here we have done a mistake. So this is not E dash, this is F dash. So go for the line option now. So we'll join the outer edges, B1 to B, and then we have got C1 to C, then D1 to D, E1 to E, and F1 to F will be the dotted line again. So F1 to F will be the dotted line. So you can just see that they're not actually overlapping. There is some slight difference that you can see. So this is the front view of the hexagonal prism. So let us join the axis points. Select a line of thickness 0.13 and let it be a center line. So from O1 to O dash. So this is the axis. So if at all you're asked to measure the length of the axis in the final position, O1 to O dash. So this is the length of the axis in the final position. So with this, we complete the drafting of the solution for the given problem statement. So to sum up, we have got a hexagon prism which is having its edge length as 25 and axis length as 50 mm, resting on one of its edges. Here it is A1, B1. So we have not annotated the axis point here. So this is O01. And then its axis is inclined to the HP at an angle of 45 degrees. This is the front view and the top view. And also he tells that it appears to be inclined to the vertical plane at an angle of 40 degrees. So this is the 40 degree, which is the given beta angle. And we have placed the axis O and O1 on this 40-degree line, then drawn the front view of the prism. So you can indicate the direction of the projection lines using the leader option. So with this, we complete the drafting of the solution for the given problem statement. Thank you all for watching.